Hello everybody, and welcome to the North Carolina Smart Grid Basics webinar. We are pleased that you decided to take a little time out of your schedule to join us today. My name is Alex Glenn, and I work with Advanced Energy as a training consultant and instructional designer. I've worked in the energy industry for 15 years, and I'm happy to be your host and facilitator for today's webinar. As an independent nonprofit that works with most of North Carolina's electric utilities, Advanced Energy's mission is to help our state's electric utility customers get the most value out of the money that they spend for energy. To help our state's residents make well-informed energy decisions, we want to share information about new technologies and services when we believe they can offer value, and also want to share any concerns that may present risk. This webinar series is being developed using the North Carolina Public Benefits Funds administered by Advanced Energy and Duke Energy, along with generous technical support from North Carolina's electric membership cooperatives, Duke Energy, and Dominion NC Power. North Carolina's electric utilities are in the midst of modernizing their power generation and distribution systems. This transformation of our electric grid offers improved performance and growth opportunities for citizens, communities, and businesses. We're excited to launch this webinar series to bring you information about smart grid technologies and systems that are being deployed in North Carolina and how you might be able to benefit from them. The webinar series begins today with Smart Grid Basics and continues with additional smart grid topics planned for the remainder of 2017, including solar power and grid integration, smart meters and advanced metering infrastructure, microgrids and grid resiliency, and self-optimizing systems. Please join us for the entire webinar series, as each one will cover new information as well as the relevant connections between these different technologies. We'd like to hear from you during today's webinar. Please post your questions and your comments in the Q&A box up on the right side of the screen. We will answer as many questions as we can at the end of the presentation. I also want to remind you and to mention that we've developed a new website where we'll be making additional smart grid resources available. We'll be posting case studies, educational videos, upcoming events, and links to all of the resources. So please make sure to visit ncsmartgrid.org if you're interested in more information. Please note that a recorded version of this webinar will be made available to you. We will send out a follow-up email with a link to access the webinar recording, as well as additional links to those valuable smart grid resources. In today's webinar, we'll take a look at our electric grid and provide a high-level overview of some of the smart grid technologies that are being implemented across the state. We will also discuss potential benefits of those technologies for customers, businesses, and local governments, and start to explore the challenges and opportunities of the different technologies. I'd like to introduce you to our presenter, Cyrus Doster. Cyrus is an energy consultant here at Advanced Energy, and he's worked on our building science and engineering teams. His current work focuses on electric vehicles, solar assessments, and smart grid education. At this point, I'm going to turn it over to Cyrus, who will give us a little more detail about today's agenda, and will also deliver our presentation.
Thank you, Alex, and thanks to all of you who have joined us today. As Alex mentioned, today's session kicks off our series, and this slide gives some more detail on what we'll be covering today. We'll start with an overview of the existing grid, talk about the electricity landscape in North Carolina, and then get into what makes a smart grid a smart grid. Smart grids offer potential value in the areas of customer service, economic growth, municipal readiness, and community sustainability, and we'll introduce some of the opportunities for customers, businesses, and local governments. We're living in a great time for smart grid, with technology advancements, policies, and economic growth opportunities aligning to help ensure that those benefits will be realized. 4 key technologies are being deployed across the state as we speak: solar power, smart meters, microgrids, and self-optimizing systems. I'll introduce those today, and of course, very few, if any, technologies are perfect, so we'll cover not just the opportunities, but also some of the key challenges of each technology. I also want to let you know that we're using a hybrid model for today's webinar, and the upcoming section is pre-recorded. While you're watching, please feel free to submit questions, and as Alex mentioned, we'll do our best to address them when we return to live discussion. Before we get into what a smart grid is, let's take a few minutes to understand the traditional grid. First of all, what is it? How is it set up and operated in North Carolina? And what are the reasons that we should modernize the grid even though it's working really well? One way to define the grid is that the electric power grid is a system of wires, switches, and other equipment that brings electricity from where it's generated to where it's needed. And you'll see I've got grid in quotes because to me it's a bit of a misnomer. A lot of the grid does not have a regular orderly structure like city blocks. It's really a huge web-like network, as you can see in this graphic from Argonne National Labs. All this shows is our high-power transmission grid. It doesn't even include the distribution wires that take power all the way into our neighborhoods to our homes. Now, it's important to know that most of the existing electric grid was developed as a system of large, centralized electricity generators that delivered energy in just one direction, from the power company to the customer. And that grid was built out over the past century to provide safe, reliable, and affordable electric service, and it does exactly that. It's widely regarded as a marvel of engineering, the largest interconnected machinery ever built by humans. Turning to North Carolina, our grid is used by 3 main types of utilities that are regulated in different ways by our Utilities Commission, public staff, and legislature. We could spend a long time on the details of utility business models and regulatory oversight, but for today we're going to stay at a pretty high level. In a nutshell, the 3 main types of electric utilities are electric membership cooperatives, typically called co-ops, investor-owned utilities, referred to as IOUs, and municipal-owned utilities, called munis. Electric cooperatives are owned by their member customers and are controlled primarily by their boards of directors. More than 24 co-ops serve about 1 million members across the state, and the map at the upper right shows you the different service territories that the co-ops cover across the state. Investor-owned utilities are owned by shareholders. They include Duke Energy Carolinas, Duke Energy Progress, and Dominion NC Power. These IOUs serve about 4 million customers, and the middle map shows the blue with Duke Energy Carolinas, in green, Duke Energy Progress, and Dominion NC Power covering the gray area in the northeastern portion of the state. Now, the munis are owned and operated by a town, a city, and even a couple universities across the state. We have more than 70 municipal utilities, which are generally members of either NC Public Power and/or Electricities of North Carolina, and they serve about 500,000 customers. Turning to our regulators, the Utilities Commission regulates all aspects of service for investor-owned electric utilities and 2 university-owned utilities, including electric rates and the construction and operation of power plants. The Commission does not regulate rates or services for co-ops and munis, but they do oversee certain complaints, assess compliance with legislative mandates, and they also grant certificates for the construction of their power plants and transmission lines. The North Carolina Public Staff represents and advocates on behalf of North Carolina electricity customers in all issues that are considered by the Utilities Commission. And it's a common misperception that the public staff is a part of the Commission, whereas it's actually an independent entity. So the public staff provides review and recommendations to the Utilities Commission on rates, services, standards, and complaints. The public staff also provides information and guidance to legislators, municipal staff, and third parties who intervene in issues that the Commission is considering. Finally, our state legislature has approved several key pieces of legislation since the late 1970s that have done a lot to shape the way our grid is designed and the way that it's used. This next slide shows the North Carolina electric generation mix. This information comes from the Energy Information Administration, and let's take a second to just kind of orient to the graph. On the left side, the units aren't really important, but it shows the amount of electricity that we're consuming in the state. On the bottom axis, we have the years, and we're looking back here across about 25 years from 1990 through 2015. And then in the field, we see how much electricity was produced from all of the different fuels that North Carolina uses in its generating facilities. And you can see we have a really diverse mix. The dark gray at the bottom is coal-fired. The orange is nuclear-generated. The light blue is natural gas-fired generation. The green is biomass. The dark blue is hydropower. This yellow that's pretty hard to see, a little sliver in here, that's solar. And then the dark line at the very top is just a little bit of petroleum that we do use for generating electricity. And I think it's interesting to see that our electricity use grew almost 50% between 1990 and 2005, but since then it's actually declined or stayed flat. So we're doing a good job at managing our overall electric consumption. You can also see that our fuel mix is changing. The most dramatic change is this really large increase in the use of natural gas from a little after 2010 on, and you can see that that's translating to a similar decline in the amount of coal. And as a matter of fact, we're using about half as much coal now as we were back in about 2007. You can also see that solar production has grown a lot in the past several years, but it's still a small fraction of the state's total electricity production. Once our 2016 and 2017 data is included, though, it looks like solar generation may match or exceed the generation from biomass. Now, we have a safe, reliable, and affordable power system, but there's still many reasons to improve it, and that's leading to our drive to modernize the grid. So what are some of those reasons? First of all, a lot of the grid has been in place for many decades. That infrastructure is aging, and it needs to be replaced. We're also incorporating a lot more distributed energy resources onto the grid. And when we say distributed energy resources, we mean smaller sources of power that are located closer to the loads that they're serving, rather than the large centralized power plants which were part of the original construction of the grid. A lot of those distributed energy resources, solar and wind in particular, are also variable. They don't put out constant power over the course of entire days, weeks, or even months, like coal-fired, nuclear-fired, or natural gas-powered generators do. There's also customer demand for new services. In today's day and age, we're accustomed to having control and access to data in a lot of aspects of our life, and customers would like to have the same types of control and convenience with their electric service. Unfortunately, we also live in an era of new electronic and physical threats to our grid, and having a smarter grid can help manage and minimize those threats. We also have more people living in regions that are affected by severe weather. So even if we don't have more weather events, more people are going to be affected by the ones that do occur. And finally, we have a lot of sustainability requirements and goals in place, and Smart Grid can help us integrate clean energy sources and improve efficiency. Now, fortunately, we've also gotten to a point in time with technology where we have the advanced sensors, controls, and communications that are needed to address these issues, and those technologies are also now affordable enough to enable modernization. It's hard to boil down Smart Grid to just one sentence, but here's one way that we can define it. A smart grid integrates new technologies and communication networks with a conventional grid to benefit customers, their communities, and their power companies. And it's important to know that a smart grid can take a lot of forms. It isn't just one particular plan or design, and different utilities can and do focus on certain technologies first. For example, here in North Carolina, all of our utilities are working to integrate solar power because it's being installed all across the state. Our electric membership co-ops were ahead of the curve, and they switched almost completely to smart meters several years ago, whereas Duke Energy focused on distribution upgrades first and is now also deploying smart meters. So depending on which utility you're a customer of, you may see different services available at different times. Here's another way to visualize a smart grid. It's an integration of modern power technology on the electrical infrastructure with an overlay of advanced communications and controls as what we might call an intelligence infrastructure. And working together, that electrical infrastructure and intelligence infrastructure facilitate the flow of electricity and information both to and from customers. At this point, we've covered a bit of background on what the power grid is, how it's set up, and how it works here in North Carolina. You've heard some reasons for why we're transitioning to a smart grid and what that means on a high level. Now let's come back to the benefits that a smart grid can offer. Smart grid can offer benefits to just about everyone who either uses or produces electricity, but the key phrase is can offer. We need to make sure that any technology is used appropriately so that we get its benefits. In the next few slides, we'll talk about those benefits, which can be loosely grouped into these four categories: customer value, economic growth, community sustainability, and municipal readiness. So So let's look at each of those areas to paint a quick picture of what they represent, and then we'll talk about some opportunities and risks of specific technologies that can deliver those benefits. With a smart grid, customers can gain knowledge of and control over their electricity usage. Outages will be shortened and in some cases avoided completely. We've gotten very used to having control and access to information instantly thanks to our mobile devices and the universe of apps that are available for them now. And now our utilities can provide new services with those connections. Grid modernization is also creating business opportunities for North Carolina, including new and exciting career paths for students and current employees. A smart grid supports economic growth because improving the reliability, affordability, quality, and sustainability of electric power helps North Carolina both attract and retain businesses, especially in industries that need high-quality power, such as pharmaceuticals, data centers, and manufacturing. North Carolina already has hundreds of companies serving the smart grid supply chain, from early-stage startups to multinational businesses. Now, there's no denying that the switch to a smart grid is very driven by technology, but please know that you don't have to be an engineer to be a part of the transition. Several of the other careers that come with a smart grid include enhanced customer service, employee retraining, software development, data analytics, business planning, legal compliance, and policy development. And we're really fortunate in North Carolina to have a strong education pipeline in both our community colleges and our universities, which have spun off several business initiatives themselves. So if you or someone you know is interested in smart grid, North Carolina is a fantastic place to be. With regard to sustainability, residents, businesses, schools, and other organizations have new tools to meet their goals and improve efficiency. And we're not just talking about environmental sustainability here. There's also economic sustainability. Modernizing the grid can create revenue opportunities in rural locations in particular. For example, rezoning properties to permit energy production can generate new income for landowners and improve the tax base for local governments. Communities can improve the resiliency of their critical infrastructure and prepare for residents and businesses to install new energy technologies. Improving resiliency, which here means maintaining services in spite of an outage, might take the form of providing a backup power system for emergency services or for water treatment facilities. Local governments also need to be ready for residents and businesses who need permitting and inspection services for new technologies like electric vehicle charging or battery storage systems. Now let's focus on several modern grid technologies that are already operating in North Carolina to deliver those benefits as we speak: solar power, smart meters, microgrids, and self-optimizing systems. These are all systems where the stars are aligned or aligning in those three areas of technology, policy, and economic growth. The technology works in the real world, the products are readily available, and they're also coming down in price. Policies either support or at least don't hamper their deployment, and these systems can provide cost savings or services that are wanted by the market and can provide a return on investment. We've focused mainly on the possible benefits so far, but we need to balance the opportunities and benefits with the challenges and risks. Almost no technology is perfectly good or bad, and getting good results is going to depend on how they're installed and how they're used. A great example of the interplay between technology, policy, and economic development fueling the creation and growth of an industry is solar generation in North Carolina. We now rank second among all U.S. states for total solar capacity, with enough installed to power over 340,000 homes and representing about 3% of our total electric generation. So even though North Carolina's solar investment tax credit expired at the end of 2015, growth is continuing, and the majority of new power capacity installed through this year will be solar. Now, there are a couple challenges with solar. First is its variability. The graph on the left side of the screen shows several good solar production days at a site, and you can see that even on days with lots of sun, there's also a lot of variation from minute to minute, and that has to be handled by the grid. A second challenge is quality assurance. A lot of the solar capacity is being installed by independent developers, and we need to ensure that design and installation can meet or exceed the safety and reliability standards of the existing grid. Smart meters are a key technology for enabling new customer services, tools, and choices. Smart meters are digital meters that do a much better job of measuring our electricity use, can communicate directly with our power company. You may also have heard the term AMI when people are talking about smart meters. That stands for Advanced Metering Infrastructure, and it refers to not just the smart meters, but also the systems that store and manage the data and then evaluate the data to provide useful information. I mentioned earlier that our co-ops have been leaders in deploying smart meters, and they have also implemented other parts of AMI like customer web portals and prepay billing programs that are highly popular with their members and that have created clear savings for both the members and the co-ops. So when we think about smart meters, on the benefit side, we have better control, convenience, and customer service. But we do have some risks that come along in terms of privacy and security of data and the control systems. Microgrids are independent power systems that can take over for the electric grid during a power outage. And technically, even a small gas-powered generator can create a microgrid. But for the purpose of talking about microgrids in conjunction with a smart grid, we're talking about intelligent and automated systems that can also include energy storage and renewable generation. Microgrids have been used for many decades, but new technologies and designs can make them more affordable and effective. The pictures here show Duke Energy's McAlpine microgrid, and that microgrid can provide power to Charlotte's Fire Station number 24 if the main grid has an outage. This microgrid is one that does have both solar generation and battery storage to extend the amount of time that it can operate in what's called islanded mode, where it's separate from the grid, and it has a control system that can seamlessly switch back and forth from grid connected to islanded without disrupting any of the fire station systems. Benefits of a microgrid are improved reliability and resiliency for critical and remote facilities. The risks are that whoever implements the microgrid may have a higher cost depending on the application, and they probably need to have some specialized employees for the design and operation of the system. Lastly, self-optimizing systems are similar to microgrids in that they improve reliability, but they're integrated with the grid at all times. The addition of sensors and communications to the power grid helps electric companies manage the grid system more efficiently and repair damage more quickly. So these new systems allow the grid to automatically improve performance or detect damage and reroute power. One type of system enhances grid efficiency, and the graph on the left illustrates one of those systems as it responded to a record cold temperature snap 2 winters ago. The bottom shows the time of day, and you can see it's morning. We're showing data collected between 5 a.m. and 10 a.m. And as we go up, the load on the electric grid is increasing. As the load on the grid ramped up, the system detected that it might exceed the generating capacity. So the system went into a higher efficiency mode to ensure that there was adequate capacity, kind of like switching a car into eco mode versus performance mode. Once the user load started to decline, the grid could be switched back into its regular mode and return to operation without anyone having any loss of power. Another type of system is called a self-healing network, and this is where sensors and switches are added to an area of the grid that can be provided with power from more than one direction. When damage is detected, the switches are controlled to reduce the area with an outage as much as possible and to reroute power from other parts of the grid to as many people as possible, especially where there are critical facilities like hospitals. So similar to microgrids, the benefits are improved reliability and resiliency, but these systems can also improve efficiency and sustainability. And also similar to microgrids, these systems can add expense and complexity to the grid. So these 4 technologies, solar, smart meters, microgrids, and self-optimizing systems, represent technologies that are being deployed all across North Carolina as we speak, and that we're keeping an eye on in terms of how you can take advantage. That brings us to the end of the Smart Grid Basics presentation, and I hope it started to paint a useful picture of both our existing electric grid and the transformation that it's undergoing here in North Carolina. At this point, I'll turn it back over to Alex to recap and take us into the Q&A portion.
Thanks so much, Cyrus. You certainly covered a lot of ground and definitely helped all of us gain a better understanding of how a smart grid works. You know, I think it'll be very interesting to see the new technologies come online and to watch how they play a part in North Carolina's transition to a smart grid. Before we get into the Q&A period, we'd like to remind everyone that today's webinar was the first in our series. The conversation will continue in 2017 with additional webinars on solar power, smart meters, microgrids, and self-optimizing systems. We're excited to take a deeper look at these technologies, and we hope that you'll join us again. Please keep a lookout for an email invitation with registration information for these upcoming webinars. Also, we'll be sharing case studies, educational videos, and upcoming events at ncsmartgrid.org. At the website, you'll find links to a wealth of additional information from organizations such as the Smart Grid Consumer Collaborative, the Department of Energy, and the Electric Power Research Institute. Just a quick note that we will follow up with you after this webinar by sending an email with a website link, a copy of the webinar recording, and a brief satisfaction survey. Please help us by filling out the survey so that we can continue to make these webinars valuable to you, and as always, your feedback is greatly appreciated. At this point, we'd like to take a few minutes to answer some of the questions and comments that have come in during the webinar. Please understand we may not have the time today to answer all your questions, and we may not have an immediate answer to a question. If that's the case, we'll do our best to follow up with you after doing some research or finding the best resource. So, Cyrus, let's take a look at some of the questions that have come in. What do you see?
We have just a couple, Alex, and these are questions that we often get when we talk to folks about smart grid. One is, does having a smart grid make us more vulnerable to a cyber attack? The answer to that is probably yes and no. By layering on communications and controls to the grid, we can introduce new risks. So the people designing and installing those systems have to do that with security integrated from the start. On the other hand, we're already vulnerable to cyber attack. One case that you may have heard of in news reports was the attack on the Ukrainian power grid a couple winters ago, and we may be vulnerable to a similar attack. But smart grid upgrades can actually address those vulnerabilities. And we should all keep in mind there are also physical risks. The Metcalfe, California substation attack is one you might also have heard about, and in that case, the communication technologies in place at that substation actually alerted operators to the problem as it unfolded. Another question is regarding whether a smart grid would eliminate power outages. Short answer is no, because it's virtually impossible to eliminate all outages. Most of them are caused by trees, animals, or vehicle impacts, and those are impossible to completely prevent. But almost certainly, grid modernization will reduce the scope and duration of outages, as I mentioned earlier. The technologies being installed are reducing the number of people affected and truly helping power companies detect and find the source of the outage faster. And we'll have some statistics on that when we get into the self-optimizing systems webinar later in the series. We've had another one come in just now. The question is, how much will Duke's grid modernization ease the interconnection of solar? Specifically, how much of a difference will it make in terms of interconnection costs, and how much more solar will be able to be integrated or interconnected to the grid? With a current estimate, or Duke currently estimating 20%. And Dave, I have to apologize. That question is a little deeper than I can answer to you directly in this moment. I can tell you, based on my personal experience with solar farm assessments, that the new technologies on the grid side of the interconnections are improving the ability of the farm to be integrated and for us to assess the quality of that interconnection. And I think everyone is still really figuring out how the costs are going to play out. This 2017 will be another big year for interconnections for North Carolina. And between that and last year, I think we'll be really getting our arms around how that will play out as both the developers and the utilities get more comfortable and familiar with the processes. And with regard to the cost question that you bring in, we also have a question about what is the cost to make the conversion to a smart grid. And you'll see varying estimates from a national perspective where you probably would be looking at hundreds of billions into the trillions of dollars to do a complete upgrade and modernization. To bring it back locally, you may have heard of Duke Energy's announcement just a couple weeks ago that they'll be investing $13 billion over the next 10 years on grid improvements. And that's in addition to the several $billion that they've spent in recent years. So as a frame of reference, Duke is certainly the largest power company in our state. They're also the largest power company in the nation, but they're just one of several thousand power companies. So multiply that investment and you can start to get a sense of that. And finally, field one more. We've got a question on speaking more to the savings that customers can experience by having access to advanced metering infrastructure, especially with regard to cooperatives. And so in the presentation, I referred to two ways that specifically the co-op implementation of AMI is supporting customer services. One was giving their customers quicker access to their consumption information, and another was to be able to offer a prepaid billing program. And prepaid billing was really interesting to me. As a matter of fact, we are in the middle of creating a case study with a video on the Brunswick Electric Membership Corporation's prepaid billing program, and we hope to have that ready in time for the Smart Meter webinar. But in the meantime, my initial reaction was, prepaid billing in terms of cutting people off, when they've used up their account may sound a little harsh, but in the reality, it's been met with incredible customer satisfaction. And the reasons for that, it turns out, are that there's a good number of customers that really benefit from ease of connecting and disconnecting. For example, military customers who may be deployed on short notice or be relatively transient in their housing and need for power connections. And having a prepay setup eliminates a lot of the back and forth and the setup costs of creating a new account or closing an account. It also allows folks who may have a poor credit history to start a utility account without having to have a credit check. And in the data that's coming in from Brunswick so far, they're seeing reduced costs for both customers in terms of reducing their electric consumption, reducing any penalties they might have to pay for late payments, and also on the utility side, improving the payment quality and the number of payments or reduction of delinquent payments. So with that, I think I'd like to wrap up. I really appreciate everyone for submitting those questions and turn it back to Alex.
All right, Cyrus. Well, thank you for that, and those were certainly some very thoughtful questions. Thanks to everyone who submitted one of those questions or the comments. At this time, we need to move on and wrap up with a reminder of the resource links and a satisfaction survey. At the end of the webinar, when you close this, a survey will pop up in your web browser. In order to help us make these webinars more valuable for you, please provide us with your feedback. Also, as a final reminder, we will be sending out a follow-up email with resource links and a recording of today's webinar. We'd like to encourage that you share this webinar and the resources with your colleagues and industry contacts. Please feel free to forward that email to your network when you receive it. We're grateful that you chose to take time out of your day to join us for this webinar. We hope you have a great day and take care.